Alright, welcome. In this video, I'm going to be working Algebra 2 Homework 6.2, which is all about sketching more polynomials and multiplicity of roots. So these first four, it's like factor it first, and then sketch the graph labeled the x and y intercepts. Okay, so our first job is factoring. So the first thing I'm going to need to do is look at this and see, is there a greatest common factor? And there is. I can factor out an x out of all three terms. And then I can factor a little bit more. X times, okay, looking for two numbers that multiply to negative 40 while adding to negative 6. I'm thinking negative 10 and positive 4. Okay, so I've got it fully factored, and I'm going to be ready to sketch the graph now. Okay, so I'm going to start with an x-axis, and I'm going to label the zeros. So it'll be x equals 0 from this factor. And that might not end up being x equals 0. I've got three different zeros. I'll label them first, or I'll plot them and then I'll label them. Okay, x equals 0, that's going to be here. X equals negative 4 from that one, and x equals positive 10. Okay. And then I need to think about the end behavior of this polynomial. So this is a third degree polynomial with a positive leading coefficient. Okay, and I'm seeing that from this term right here. Okay, 1x to the third is the biggest power of x I'm seeing. Okay, since it's an odd degree polynomial with a positive leading coefficient, I know it's in general going to look like the graph of y equals positive x cubed. Okay, which is to say it's going to come from below and eventually go up. Okay, and since all three of these are single roots, we know that the graph is just going to pass through confidently at each x-intercept. Okay, and then we've got ourselves a sketch. Okay, we also need to label the x and y-intercepts. We'll always have the x-intercepts labeled because that's how we're sketching. The y-intercept is something we might need to come in and do at the end. Okay. Now with the second one, I think this should be a little easier to factor. I'm going to say, all right, I'm going to factor out an x squared, and I'll be left with a 1 plus x. Okay, it's fully factored. So this is a third degree polynomial with a positive leading coefficient, again, okay, based on this biggest term I see. And I'm going to draw an x-axis. Wait, I factored out x squared. And I'm going to label my zeros, okay? I'm going to have zeros where x squared equals 0. Okay, that's x equals 0. And where 1 plus x is equal to 0. 1 plus x is going to be equal to 0 at x equals negative 1. Okay. Now, I need to remember that because of this x squared, x equals 0 is a double root. Which means that when I get to that x-intercept, the graph is going to bounce and not pass through the x-axis. Okay, so degree 3 positive leading coefficient means overall it looks like y equals x cubed. Or like the previous one, it's going to come from below, it's going to go, okay, 1 plus x is a single root, so graph's going to pass through confidently, but then when I come towards 0, it's going to bounce because of the even multiplicity, right? It's got multiplicity 2 because of that x squared. And that's going to be a good sketch. We can come through these ones where x equals 0 is a x-intercept, are really easy to sketch the y-intercept of too. I kind of like those. And then we've got ourselves a sketch. Alright, here's two more. Oh, there's even more. Alright, so we're going to be factoring. I like to always start by factoring out the negative. But wait, maybe I could do a little more. I could factor out a negative and an x. So then I'd be left with x squared minus 10x plus 25. And this is something I'm going to be able to factor. That's going to be x minus 5 times x minus 5. And since now we know what, a repeated factor will do on our graph, I know it would be good for me to write this as x minus 5 squared. So I can be reminded that x equals 5 is a root with multiplicity 2, or a double root. Okay, so I've got it all factored. I'm going to draw my x-axis, get my zeros. Okay, so this will be equal to 0 when x is equal to 0, or when x is equal to 5. And x equals 5, that's a double root. Alright, this is a third degree polynomial with a negative leading coefficient, okay, negative x to the third. So what this is going to look like the graph of y equals negative x cubed, which would mean that it's coming from above, and then eventually it's going to be going down as well. Okay. It's coming down. X equals 0 is a single root, but x equals 5 is a double root. Okay, that didn't go maybe as well as I'd hoped. Didn't lose that much. Oh no, lost everything. Alright, try again. Alright, what's going on here? Alright, there we go. And we'll bring in a y-axis so as to label our y-intercept, and then we'll have a nice sketch. Number 4. This one, I could see we're going to factor out a 4. I'm definitely receiving that message, so I'm going to do that. 4 times x to the 3 plus x to the 2 plus x plus 1. Okay, 4 things together, that must be group and factor. So I'm going to factor out an x squared out of the first 2 terms. And then I don't see anything to factor, so I'll factor out a 1. So I can be left with that x plus 1 on both sides. And I'll factor out the x plus 1, and I'll be left with x squared plus 1. Oh yeah, okay, I'm glad I put this one on. This one's a little tricky. So, we've got to think about the zeros. Okay, y equals 0 anytime that 4 equals 0, well that's never going to happen, or when x plus 1 equals 0, or when x squared plus 1 equals 0. Now, x squared plus 1 equaling 0, that's going to mean that x squared equals negative 1. And at this point in the course, that's not possible, right? We take any number and we square it, we're going to get a positive number, unless we squared 0, and then we would get 0, but we definitely would not be able to get x squared equals negative 1. So that's not going to contribute any solution. So this just has the 1x intercept. And I go in and I'm going to draw my x-axis. But I can say that the y-axis is going to come through here. Okay, and okay, I'll know that that y-intercept is y equals 4 because of that number right there. Okay. We labeled the x and y-intercept, yeah. All right, 5 and 6. It just looks like more of the same here. So I'm going to factor out 2x to the 3. Or maybe I'll factor out negative 2. Oh no, that's not good. And then I can go a little farther. All right, this is a difference of 2 squares. That's an interesting factoring. So it'll be 1 plus 2x and 1 minus 2x. All right, and so I think I might label my zeros in this case. I probably should have been doing that the whole time. Okay, so I've got x equals 0, which is a triple root. I've got 1 plus 2x equaling 0. That will give me x equals negative 1/2. Yeah, that would make that factor equal to 0. And if x was positive 1/2, if I plugged that in there, I would make that factor 0. Okay, so I've got my x-intercepts. I'm going to label them negative 1/2, 0, and 1/2. Okay, and this is a 4th degree polynomial with a negative leading coefficient. So it's going to look like y equals negative x squared. Okay, so that means it's going to kind of come from below. Now, negative 1/2 and positive 1/2 are single roots, so the graph will pass through confidently. It'll bounce at 0 because that's a double root, and then it will come back down through with confidence and go down, you know, respecting its own end behavior. So draw ourselves a y-axis, and now we've got a good sketch. Number 6, I'm going to factor out at least an x squared, but also a 3, because 3 divides 48. So y equals 3x squared times 16 minus x squared. Y equals 3x squared. 16 minus x squared is a difference of 2 squares, so that would be 4 plus x and 4 minus x. And, okay, my x-intercepts will be x equals 0, which is a double root. X equals -4, single root, and x equals +4, that's also a single root. Okay. Now I'm going to label these, -4, 4, and 0. This is the exact same... Oh my goodness. What have I done? Oh boy. I was not respecting the fact that... Wait, how's that going to be possible? 3, 4... Oh my goodness. That work in red is just an abomination. I'm just going to have to ask for your forgiveness, and I'm going to go back and I'm going to work that one again. I just was not... I made a factoring error at the very beginning, and then, yeah, somehow made it work. Didn't catch myself. Alright, so I'm going to finish number 6 first. Okay, so -4, it's the exact same problem. 4, no, 0 and 4. Fourth degree, negative leading coefficient. That hasn't changed. So it's going to come from here and actually look like what I just drew. Alright, so let's go back to number 5 and correct the error I made. And, okay, if I factor out a -2x to the 3, I'm left with a 1, but I'm just left with a -4x. Yeah, okay, that's way different. And this is going to give me, oh wait, so, yeah, just 1 minus 4x. Okay, so I was done factoring after one step, and then I've got x equaling 1/4. We'll solve that, and that's going to be a single root. So I go over here, 0, 1/4. This is a fourth degree polynomial with a negative leading coefficient, so it's going to come from below and then eventually go down as well. But here at x equals 0, it's got a triple root, so it's going to hesitate. I didn't really like that one, so it's all right. I can just try again. There we go. That one was much better. And then it's going to come down through 1/4 with confidence and connect on down there. Okay, you wouldn't want to forget to label my y-axis. And there we've got ourselves a nice sketch. Alright, now we're just going to be given a factored form polynomial and asked to sketch it. So this is just more about the sketching and less about the factoring. Although the factoring is still very important. Okay, so we're going to say, alright, start with the zeros. Okay, x equals 5, that's a single root. And x equals -2, that is a triple root. If I was to multiply this out, this x minus 5 times x plus 2 to the 3, I would end up with I have 4 powers of x, and the leading coefficient would be +1, because each time I'd just be multiplying x by some other power of x. So I'm going to say that this is a degree 4 with a positive leading coefficient. And I'm going to label my axis. Oh wait, so because it's an even degree with a positive leading coefficient, it's going to look like y equals x squared. And let's say -2 and +5. And then the graph is coming through, and no, -2 is the triple root, so it might help if I just brought that over a little bit. Yeah. And x equals 5 is the single root. On the outsides, it's going up on both sides, and then it's, looking like a single root at x equals 5 and a triple root at x equals -2, so this is a good sketch. I'm going to say, alright, I'm thinking that the y-axis should go somewhere, I don't know, right about there. We don't really know where it's going to be, especially with respect to like that bottom point right there. We don't have the tools to know that yet, so we're just kind of giving it the best guess we got, and we'll label our y-intercept, and we can say what that's going to be. Okay, so the y-intercept, that's going to be, well, what I get for y when x equals 0. Okay, so x equals 0, and y is going to equal 0 minus 5 multiplied by 0 plus 2 to the 3. So that's 2 to the 3 is 8, times -5 would be -40. So this is not really drawn to scale, but we can just label it like that, and now it is. Okay, number 8. I've got here what looks to be a second, third, fourth degree polynomial, right? Because I've got 2 here, 1 power of x there, 1 power of x there. So this is degree 4. The leading coefficient is going to be negative because of this negative 2 right here. So at least on the outsides, it's going to look like y equals negative x squared. I'll list out my x-intercepts. X equals 0 from that right there. X equals 3 over here. Those are both single roots. And x equals 5, which is looking like a double root to me. So I'm going to label those 0, 3, and 5. And if this is a fourth degree polynomial with a little negative leading coefficient, maybe I should just move that up a little bit. Okay, and then I'm going to say, all right, it's coming from below. X equals 5 is the double root, so that's where it's going to bounce. So it's going to pass through confidently at these points. Ooh, didn't love that, but it'll do, right? We don't need these to be perfect. That's why they're just a sketch. You can get a y-axis, and I'm good to go. All right, numbers 9 and 10. This is going to be a third degree polynomial with a positive leading coefficient. My zeros are going to be x equals negative 1, which will be a double root, and x equals positive 1, and that's going to be a single root. Go over here, label these, negative 1 and 1. And if it's a degree 3 polynomial with a positive leading coefficient, it's going to look more or less like y equals x cubed, at least on the outsides. Which means it's going to come from below. Go up, x equals negative 1, that was the double root. Okay, so that was not really looking right. It's got a bounce there. And then it's going to pass through confidently at x equals 1 because that's a single root. And then I'm going to bring in a y-axis. Oh, you know, I think I drew the y-axis on the last one, but oh no, okay, it didn't matter because 0 is a factor. I did label it. Okay, I'm going to need to figure out the y-intercept here. Gray. For the y-intercept, x is going to equal 0. And y will equal 0 plus 1 squared times 0 minus 1, and that'll be negative 1. All right. Then this one, negative x plus 10 cubed. Okay, so this is a degree 3 polynomial with a negative leading coefficient. And it only has the one x-intercept, that's x equals negative 10, which is a triple root. Oops. In some sense, it's going to look like y equals negative x cubed. So we go over here, label that negative 10. So it's coming from above, it's got a triple root, so it's sliding through and then it's going down. But like, look at that. That looks just like the graph of y equals negative x cubed. And so I think the point I'm trying to make here is that kind of like what we saw with the vertex form of a parabola, the graph of negative x plus 10 to the 3 is going to be the same as the graph of negative x cubed, but just, move to the left by 10. Now, when we go to draw a y-intercept here, this is going to be 10 to the 3, that's negative, so it's 1,000, and then if I made it negative, so I'll show you that. For the y-intercept, I'm going to let x equals 0, and y equals the negative of 10 to the 3. And because exponents come before multiplication by negative 1, it's going to be negative 1,000. All right. Now, here's a couple where one of the zeros is given, and then we're going to sketch the graph. Okay, if one of the zeros is given, then we'll use it with synthetic division to hopefully factor it down. All right, so f of 1 equals 0. So we're going to set up for synthetic. We're going to do negative 1x cubed, positive 11x to the 2, negative 34x, and positive 24. And we're going to run 1 through there because we know that x equals 1 is a 0 of the polynomial, meaning that x minus 1 is a factor, however you want to think about it. Okay, so now we know that f of x is equal to x minus 1, because f of 1 equals 0, so x minus 1 is a factor, times negative x squared. Maybe I'm just going to factor out the negative right now. Negative x squared, so it'll be minus 10x plus 24. All right, I'm pulling these numbers from the quotient for my other factor. And two numbers that multiply to 24 and add to negative 10, that would be negative 6 and negative 4. Okay, and then we're going to sketch the graph. So I think now that I've got it factored all the way, I guess I could leave that. I'm going to say, okay, this is a third degree polynomial with a negative leading coefficient. It's got zeros at 1 and 4 and 6. Third degree with a negative leading coefficient. It's going to look like negative x cubed, so it's going to come from above. But all three of these are single roots. So they're just going to pass through confidently on all of them. Go over here, have it like that. And, okay, I can see from... Okay, so it's, standard form is good for some things. We can see that y equals 24 is going to be the y-intercept there. I guess I should probably have used that color. And there we go. Right, number 12 looks like more of the same. Negative 1x cubed, negative 11x to the 2, negative 35x to the 1, and negative 25. Right. So g of negative 1 equals 0, so I'm putting that out there. Negative 1. Okay, running it through synthetic, getting the 0 that I expect to, because they told me that g of negative 1 equals 0. What I'm mainly interested in is the quotient here. Oh, no, not again. Where I'm saying g of x is equal to x minus negative 1. Lost my place. So I'm looking at this for my other factor, that's negative x squared minus 10x minus 25. And I'm going to want to factor a negative out of that. And I can factor a little bit more because that quadratic thing here, that's going to be x plus 5 times x plus 5. So I'm going to write it as x plus 5 squared to remind myself of the multiplicity. And my zeros will be from here, x equals negative 1, and there x equals negative 5, which is double root. Okay, now this thing here, this negative, that's not going to contribute any zeros because, well, that's really a negative 1, and negative 1's never equal to 0, so that can contribute any possible zeros. Okay. Now that I've got this, I need to be thinking about the degree and the leading coefficient, so I'm saying that it's a third degree polynomial with a negative leading coefficient. And draw my x-axis here. Label my zeros, negative 1 and negative 5. Okay, degree 3, negative leading coefficient, looks like negative x cubed, or y equals negative x to the first, if you like that better. And so x equals negative 5 is a double root, so I'm going to bounce here and then pass through at x equals negative 1 with confidence. Okay, maybe I might switch that a little bit, make it a little easier on myself to graph the... Wait, oh, goodness, that was not how it was supposed to look. Okay, it's supposed to bounce at 5. Pass through confidently at negative 1. So I was going to lay it out a little bit more so I could draw a y-axis there. and say, okay, well, my y-intercept, that's going to be negative 25, and so I can right down there. That can make it look nice. Okay, and that's our sketch of g of x. All right, on this one, we're going to write a standard form polynomial that represents the graph shown below. So I think what I'm supposed to be noticing here is that I've got a double root at x equals -1 and a double root at x equals +1. Okay, I would say overall this looks like a degree 4 because it's got 3 turning around spots, and you know the arms of it open up the same direction, so it looks like degree 4 positive leading coefficient. So I'm thinking that this is going to be y equals x plus 1 squared from that double root multiplied by x minus 1 squared from that double root. Okay. I do probably need to figure out the value of the leading coefficient first. Yeah, I'm going to need to do that because I can see that the y-intercept is y equals 1. But I think we're going to just be verifying that a is 1 in this case. Yeah, we are. So what I might do, maybe I'll just label that in gray. So y equals 1 when x equals 0. So 1 equals a times 0 plus 1 squared times 0 minus 1 squared. Yeah, and that's just going to be a equaling 1 because this thing, that's going to be positive 1 when I multiply -1 times -1. So that's telling me a equals 1. Okay, so now I've got x plus 1 squared times x minus 1 squared. Now, you could square both of those and then multiply them out, but I think, you know, thinking strategically, I'm seeing this as a difference of 2 squares. So I could say that this is x plus 1 times x minus 1 squared. Yes, this is going to save me quite a bit of effort. Yeah, this is going to be x squared minus 1 squared. And we can compute that. Just doing x squared minus 1 times x squared minus 1. Yes. And then I'm going to do the first two together. That would be x squared. The outsides and the insides would add together to be -2. Wait, no. X squared times x squared is not x squared. That's going to be x to the 4. That's 2x to the 2's for the outside and inside pieces. And then the last two will multiply together to equal 1. And that's going to be my standard form polynomial. Let f be the function defined by f of x equals -4 times x minus 2 times x plus 3 to the 2 power. Sketch the graph. Alright, well, over here I've got my zeros at x equals 2 and x equals -3, which is double root. And this is a third degree polynomial with a negative leading coefficient. Because I'm seeing 2 powers of x, another power of x there, but 4 doesn't have an x attached to it, so it's not going to be, you know, contributing to the degree, nor is it going to be contributing to the zeros. And it's going to have a negative leading coefficient because of that -4 out in front. Okay. So I've got all that ready to go. The end behavior is going to look more or less like y equals -x squared, and the zeros are at -3 and +2. No, -x squared. What am I doing? I'm making a lot of errors in this one. Okay, degree 3 with a negative leading coefficient would look like that. Okay, but the thing is that the number of zeros oftentimes will kind of like trap you in, and if it's not fitting together, then obviously you've made a mistake somewhere. Okay, so that's what was about to happen. If I tried to graph a degree 4 polynomial with a negative leading coefficient that had a double root and a single root, this wasn't going to work out. So, oh, whoops, I don't know why I was erasing that. That's what it's going to look like. And come from above, x equals -3 is a double root. X equals 2 is a single root. There we go. Okay, where does f have a relative maximum? Well, specifically, okay, and this is something I didn't really talk about a whole lot in my sections in the lesson, maybe if at all, but a relative maximum, I'm talking about this point right here, little top of the hill spot. And we can't say precisely where that is. We would need to know how to do calculus to do that. We're only algebra students. So we would say somewhere between -3 and 2. And then as far as like a relative minimum, and by relative minimum I'm talking about this point, I'm going to say, oh, yeah, that's happening at x equals -3, based on the graph. Okay, and I guess that'll be good for that one. We're going to write a third-degree polynomial in standard form that has leading coefficient -1/2 and zeros at 2, -4, and 10. Okay. Oh, man. This one's going to be the one. That's the one that builds character, right? Multiplying out all these factors. So it's going to be y equals -1/2 is going to be the leading coefficient. That's that a when we factored it out. We saw that when we were studying quadratics too. A times x minus 2 times x plus 4, because x minus -4, and x minus 10. Okay. And I'm going to save that -1/2 for the very last, okay, because maybe some of the numbers will turn out to be even and it won't, induce fractions too early. So I'm going to set up for some long multiplication. Okay. I'm going to probably do these two first. I don't know why, but that'll be x squared minus 6x minus 40. And then I'm going to multiply that by x minus 2. And anything higher than binomial by binomial, I like to use the box. Okay, so this will be x to the 3, -6x to the 2, -40x, -2x squared, positive 12x, and plus 80. So I'll put this all together. I'll say that y equals -1/2 of x to the 3 minus 8x to the 2. -40 plus 12 would be -28 x to the first and positive 80. Okay, and then I just need to distribute in that -1/2. So plus 4x squared plus 14x, dividing everything in half and changing the sign. Minus 40. There we go. Looks good. All right, now these last few, I really like these. We've got ourselves a graph, and we're going to write factored form, but maybe there's a little bit of information, and we're going to need to find the leading coefficient as well. So with this one, okay, I can see that this is looking like degree 3 with a negative leading coefficient because of the 2 turnaround spots and the negative looking in behavior. And all right, so I'm going to have y equals some number times x minus -5 from that 0 right here, times x minus, oh wait, no, x minus -5, that's a double root, squared times x minus 2. I was thinking, if I multiply that out, I wasn't going to get third degree, and I was expecting third degree. Okay, so yeah, I've got it there. This is factored form. I just need to find the value of a. Okay, and so the y-intercept is 10, so I'm going to plug in x equals 0 and y equals 10, and I'm going to solve for a. All right, so 10 is equal to 25 times -2 is -50a. And then a is going to be 10 over -50, or -1/5. So y is equal to -1/5 times x plus 5 to the 2 times x minus 2. Okay, and that makes sense that we would see a negative value of a because we said this was a third degree polynomial with a negative leading coefficient. All right. Number 19, I'm seeing a single root at x equals 4, so I'd have x minus 4. Some number times x minus 4 times, okay, over here, x minus 7, and that looks like a triple root to me. Okay, we really couldn't say if that's a triple root or a root with multiplicity 5, but, since we're not really thinking about that all that much in this class, I'm just going to assume it's a triple root. Okay, and since we have no other information, there's no way for us to figure out what the value of a is. So I say maybe it's just 1, And I just have y equals x minus 4 times x minus 7 cubed. Okay, that would be nice, wouldn't it? All right, number 20, I'm seeing double root at x equals 1, so x minus 1 squared. Well, I guess I forgot the leading coefficient. Okay, some number times x minus 1 squared. The next root is x equals 3, so I'll put in the factor of x minus 3. And then another one over here at x equals 4. Okay, And I'm going to use the other point that I'm given that I can see is happening, the y-intercept. I'm going to say, okay, x is equal to 0 and y is equal to -4. Which means that -4 is equal to a times 0 minus 1 squared times 0 minus 3 times 0 minus 4. So -4 is equal to, looks like 12a to me. Yep. And so a is going to be -1/3, which again makes sense because I was expecting a fourth degree polynomial with a negative leading coefficient. I've got it. Y is -1/3 of x minus 1 squared times x minus 3 and x minus 4. Okay, that was kind of a lot. And number 21 is the last one. Clear this stuff out. All right, again, go back. Look at the x-intercepts. X equals 5, so I would have, again, forgetting that leading coefficient, but x minus 5 times x minus 8 times x minus 10. I think all of these are single roots because I'm looking at the graph and the graph is passing through confidently at all three spots, so I'm just going to say, okay, all three are single roots. Okay, I've also got this other point here, 7 and 5, so I'm going to say x equals 7 and y equals 5. 7 minus 5 is going to be 2, 7 minus 8 is -1, and 7 minus 10 is -3. So 5 is equal to 6a, and a is 6 divided by 5. No, a is going to be 5 divided by 6. And I'll say y equals 5/6 of x minus 5 times x minus 8 times x minus 10. And that's all for that homework.